Hey there! Did you know that the manufacturing industry, the industry that makes products like cars, shoes, toys, furniture, and more, employs over 15% of all people in Michigan? That's a lot of jobs.
When you think of manufacturing, you might think of people working on the assembly line building cars. But there are other careers in manufacturing too. Let's follow some digital divas to learn about their STEM careers and where they work in manufacturing.
This program is supported by Eastern Michigan University and Digital Divas, with additional support from the AT&T Foundation, the DTE Foundation, ITC Holdings, and viewers like you. Thank you.
Michigan has a long history of manufacturing. The first automotive assembly line was built in Michigan in 1913. Since then, manufacturing has been a big part of the Michigan economy.
Michigan may be known as the home of the automotive industry, but it is also home to one of the most recognizable furniture companies in the world, La-Z-Boy.
Everybody knows La-Z-Boy. They invented the recliner over 90 years ago. They were founded in Monroe, Michigan in 1927 and have been making furniture there and around the world ever since.
Let's go meet Katie Boudry, a data analyst at La-Z-Boy, to learn about data science and how her work helps to keep a global company running smoothly.
Hi, I'm Katie, and I'm a data analyst at La-Z-Boy's world headquarters in Monroe, Michigan. Data science is a newer career. It's only been around maybe 25 years or so. So there are some subsets to data science. The data scientist uses data to try to predict the future. They look at trends to try and decide what the most likely outcome is going to be. A data analyst uses data to tell what is, things that have happened in the past, give the state of the business, the state of the school, the state of people, using charts and graphs and all kinds of pretty visualizations. The data engineer is a more technical role, building the technology needed for the data analyst and the data scientist to do their job. We have small plastic parts that go into our furniture. The plastic is shot into a mold. Well, every time the plastic is shot into the mold and that mold is used, that decreases the life expectancy of that mold. And we did not have a way to keep track of how many times the mold had been used, so we didn't know when we were going to need to replace it. And we need to know that so that we can plan to buy it. So that was one of the very first projects I did for La-Z-Boy. I built and created a tool that would track the number of times these molds are being used so that we could predict when it needed to be replaced. At minimum, you're gonna need a bachelor's degree. There's many paths to get there. More and more schools are starting to offer data science majors. It's also possible to have a degree in another field and train yourself to move into the data science field. There may be a misconception that because I work with data and spreadsheets that I'm a math whiz. I'm not. I never took calculus in school. Don't ever ask me to complete a calculus problem because I wouldn't understand what I'm looking at. I do use statistics. So when I was earning my master's degree, I took multiple statistic classes. And when we're talking about statistics, most of what I use is the same things that you might have learned in 3rd, 4th, 5th grade. The minimum in a data set, what's the lowest number, the maximum, what the average is or the mean, what the mode, so that would be the most commonly occurring number, and what's the median, so that's the midpoint. halfway between the lowest and the highest number. So one of the things that I did as a kid that may have played into my love of data analytics, I did a lot of puzzles. It started because I had an eye condition and the optometrist told my parents that I should put together puzzles to strengthen my eyes. I put together a lot of puzzles. That was one of my favorite activities when I was 4, 5, 6 years old. My favorite thing about the data analyst career is there is no typical day. I have some tasks that I know happen every month or every quarter, but every day is different. I have a new challenge to explore and work on. My best day is when I've made somebody else's life easier. I found some sort of way to automate something or change a process so that instead of it taking an hour to complete, it takes 5 minutes. There are always challenges in jobs. As a data analyst, some of the challenges I face revolve around not having a clear direction on how to solve a problem. So I might be taking data from several different spreadsheets or other sources and combining them in some way so that people can see the whole picture. One data source might have the price of something, and another data set has how many were ordered. And we need to see both how many were ordered and how much it cost. So I have to be able to combine those two data sets together to have the whole picture. So it can be challenging if I don't fully understand how that data is created, who's inputting it, or what system is creating it. And if I mess it up, then I've painted a completely wrong picture. Instead of a picture of a car, we've got a picture of a flower, and that's not what we're looking for. Because my work is so varied and I'm working with so many different people, I have to learn every part of the business. So I'm constantly learning, and sometimes I get stuck. That's the hardest thing, is when I don't see the solution, but it's also the most rewarding. You may have a lazy boy chair in your living room right now. It took a lot of people, a lot of effort to bring you that chair to sit in. It's a big world, but it's also a small world. Technology is bringing us closer and closer together. And one of the coolest things about my job is I can see somebody on the other side of the globe and have a conversation and work together on a project to produce something really, really cool that will eventually end up in somebody's living room.
One of the biggest careers in manufacturing is engineering. Engineers work in all sorts of different ways in manufacturing.
Engineers are problem solvers. They figure out solutions from everyday problems to complex issues. An engineer uses science, technology, and math every day to do their job. Engineers design machinery, automobiles, healthcare appliances, and improve our quality of living.
Engineers design the products that are made in factories, but they also design the machines that make those products. With the technology we have today, you can design and engineer your own products and print them out with a 3D printer.
Next, we are going to meet with some of the girls from the Engineering Society of Detroit, Girls in Engineering Academy. They're going to tell us about how they used 3D printing to go from art to part.
The mission of the Girls in Engineering Academy is to alleviate the minority gaps in engineering professions by providing hands-on, project-based STEM education for middle school and high school girls. Something that makes GEA really special is that we not only provide engineering concepts, courses, and projects, but we also provide hands-on experience with professionals in industry. So by working one-on-one and in teams with engineering professionals from like Ford, Denso, and DTE, they gain a wide variety of experience and understanding of the different kinds of STEM professions that are out there, all before high school.
My name is Fallon Turner. I am 14 years old and I attend Renaissance High School. I attend GEA as a student. I've been a student since 2018. I'm in the 2018 cohort, and my experience in GEA has been really fun. We've learned many things to English, math, science, and engineering. I enjoy talking to other people, meeting other people, and broadening my experience in the STEM spectrum. Today, there are so many industries that are using 3D printing. Some manufacturers right here in Michigan are using 3D printing technologies to make lighter airplane parts, custom prosthetic devices, as well as small-scale models that are going to be used to prototype and test new designs. 3D printing allows us to design quick solutions for so many engineering problems. Like you can create a small piece that will connect two objects together, make anything from the smallest of tools that will fit into a machine, to a limb for an amputee, to even an entire house. 3D printing is a method of creating a three-dimensional object layer by layer by using a computer-created design. By using this computer software CAD, you can create anything and print it out on a three-dimensional figure. 3D printing is a process whereby an object is developed by a method of adding layers of material that will build up and create a 3D part. Because of this process, creating unique objects is extremely easy. You can create a one-of-a-kind object, or you can print out the same exact object hundreds of times. In manufacturing, 3D printing creates less material waste, is eco-friendly, it saves companies lots of money.
So a typical year in GEA starts as 6th grade female students. They come in the summer before they start 6th grade, and they take courses in different kinds of STEM topics: mechanical engineering, computer science, math from pre-algebra all the way through calculus. We highlight a different type of STEM profession each year. So starting in 6th grade, they'll take mechanical engineering and computer science. Then they might go into chemical engineering, and we kind of advance upon that foundation each year as they progress.
My name is Aria Rucker-Sosa. I'm 14 years old and I attend Cass Technical High School. The Girls in Engineering Academy has been a fun experience for me, and I liked how I met a lot of other girls and learned their experiences with engineering and heard their ideas and what they liked. I loved how I had the opportunity to learn these different subjects and do a lot of field trips and stuff and a lot of hands-on activities. Through the Girls in Engineering Academy in Detroit, I learned how to take a drawing and turn it into an actual three-dimensional product. To make something on the 3D printer, you first need to input information into a CAD software system. CAD stands for Computer Aided Design. I took elements of a sketch and added measurements into the CAD system. The CAD software tells the printer what to create and gives the printer more dimensions. Here's a design that my friends and I developed. We wanted to design a Jeep. To make this Jeep, we first sketched out what we wanted our Jeep to look like. Using the CAD software, we had to input our designs along with measurements. Take a look at some of our sketches. Here, we designed the rims of the Jeep. Here's a sketch of the headlights, seats. This is the chassis of the Jeep. We designed every little part of the Jeep, even the piece that connects the windshield to the Jeep. We even got to choose the colors of the different parts of the Jeep.
It's very important for these ladies to learn these engineering skills at a young age, because this is an important time as a young adult to be able to learn what is out there and something that they might be interested in the future. Whether it is engineering or STEM, computer science, digital, whatever it is that they're going to go into, this is the time that they can really capitalize on that and experience it without paying a bunch of money in college and finding out whether they like it or not. This is a great time for them to experiment and grow.
I'm Genesis Brooks.
I'm 13 years old, almost 14, and I go to Berkshire Middle School. My favorite part about GEA is the learning experience. GEA really pushes you out of your comfort zone and challenges you with different subjects, whether that be math, science, or different types of engineering. Layer by layer, it took us about 8 hours to create the body of the Jeep. And then it took us about 6 hours to create the rest of the Jeep to make it complete. If our measurements are correct, then each of the pieces should snap together. This is our final product.
The Engineering Society of Detroit created the Girls in Engineering Academy because they saw such a huge gap in the engineering profession. The latest stats from the American Society of Engineering Education that was put out in 2020 is that there are 23% of engineering degrees going to females, so 77% are to males. And within that female breakdown, only 8% are going to underrepresented minority females. So there is a great need and a big divide in this profession that the Engineering Society of Detroit is trying to alleviate. Can't fix it, we can't get rid of it, but we can at least do our best to get it where it should be.
Manufacturing is a huge umbrella. There are so many STEM careers in manufacturing. We already talked to a data analyst, and we met with some future engineers, but there are also accountants, warehouse workers, technicians, and software developers.
You know, people who work in manufacturing don't just work in a factory. They can also work in all sorts of different places, including really cool buildings. These offices can include everything from snack bars and cafes, wide open spaces, great places to meet with your coworkers, and are really equipped with the latest up-to-date technology.
Next, we are going to meet with two women who work on the technology side at the Michigan manufacturing company, Promise. They're going to tell us about how they started on their paths to working in STEM.
Hi, I'm Stephanie Price, and I'm a Senior Applications Engineer at Promise Incorporated. Promise is a manufacturing company that makes presses that are used by other manufacturing companies to make things. So an applications engineer works with customers out in the field, setting up our press systems, getting them ready to do the assembly or the test for the product that they are manufacturing.
My name is Rina Limbachia, and I am Voice of the Customer Coordinator at Promise Incorporated. Voice of the Customer Coordinator is a role that is implemented in various companies, and it involves customer experience gathering feedback, analyzing data, and being able to take that data and use it towards insight and turn it into actionable items for product development. So when I was in high school, it was very important that I figure out where I was going to go into my bachelor's and what I was going to study. I really had an affinity to get into science and do something within pharmaceuticals, do something within the medicine field. And so I did go into college with the expectation that I would be doing a degree in biomedical science. After I graduated, I was working for a pharmaceutical company where I was having a dual role as a clinical project coordinator as well as a recruiter. And I was seeing this vast amount of demand in the field of technology. And I was at a point in my life where I was still young. I felt like nothing was stopping me from going into getting a second master's. And seeing the demand in technology, I spoke to my brother. He was working as a business analyst. And I asked him, I was like, what do you think if I pursued a career in technology? And he said, it's a great idea. I pursued a second master's in computer information systems, and that's where it opened up doors for me.
I was working at a sales and marketing firm, and I knew I was going to go back to college. So my friend, Catherine, her husband was in, and he had her trying to do some type of logic problem. And Catherine was like, I can't do this, but I know who could do it. She called me into her office and she said, Stephanie, figure out this logic problem for Andy. And I looked at it and I did it like super quickly. I love logic problems. There was something I did all the time. And Andy looked at me and he said, Stephanie, you would make a great software engineer. Catherine says you're going back to college. And I said, I left biochemistry because it was not social enough for me. And you want me to be a computer science major? I'm like, I think you're crazy. And he was like, just keep an open mind. I went in, kind of checked out Eastern, talked to the College of Technology. I talked to the people in the computer science program, found out that I needed to take Intro to Java. Really, one of the key things that you learn in software engineering isn't a language. It's not that you're learning Java or you're learning .NET or BASIC. It's that you're learning how to think. And it's a lot of critical thinking skills that you learn in software development. And so having that strong basis of critical thinking skills, I've been able to take that over. And so I took Intro to Java and I was really shocked. Not only did I do well in it, I actually really enjoyed it. And I was surprised because that was something that I had never thought about for myself. It was never even a career path really that I had laid out for myself when I looked at what I wanted to do. So I decided to just kind of stick with it. It was scary to return to college in my 30s. I didn't know if I could cut it. There were so many kids that had been exposed to programming, to technology, that when I was going to school, it was brand new. We didn't have computers in my high school until my sophomore year. I mean, they had them, but people mostly used word processing to write papers. And all these other young adults, they had exposure to it that I didn't have. Everybody has their own path, and nobody's path is right or wrong. And the best part of it is that you can continue to learn and grow. And that was something that I didn't learn in my 20s. I thought that you either had knowledge or you didn't have knowledge. I didn't realize that knowledge was something that you learned. To me, learning came very simple when I was younger, and I didn't know how to study. And so when college got hard and I needed those study skills, I was like, oh, this must not be for me. I didn't go into engineering right away because I thought I couldn't do math. What I learned was that I just learned math differently, and that when I had the right person, the right professor showing me math, it clicked. So if there's something that you want to learn and you don't know it, and the first person who teaches it to you, it doesn't click, well, that doesn't mean that you can't learn it. It just means you didn't find the right person to teach it to you, and you have to try again.
When you're working for some time and then you transition into going back to school, it's a shift. I had to mentally prepare myself that, look, this is something I have chosen to do, and I want to put my 100% effort in it. When I started my master's, I felt like doing something that I was inclined to do because it was going to take me into the career path that I wanted to. I think I enjoyed it a lot more than I did with my master's in biomedical science. I think that knowing that I was going into a field where it had so much opportunity, and I know it opened up so many doors of opportunity, that I was more excited.
My thoughts on women in STEM and manufacturing is that I love that I'm seeing more women in manufacturing, and I can't wait until we have even more. It's so vital to understand that when you have diversity and people have different backgrounds, that the products that they make are more inclusive to everybody.
Today, we learned that the world of manufacturing is made up of many different jobs, and we've barely scratched the surface.
If you love problem solving and working with data and information, maybe you'd make a great data analyst. Or maybe you have a great idea for a project or invention, and you want to design and manufacture it. The manufacturing industry offers many career options for people who love STEM.
This program is supported by Eastern Michigan University and Digital Divas, with additional support from the AT&T Foundation, the DTE Foundation, ITC Holdings, and viewers like you. Thank you.